Okay, so we have log x. Yeah, we do. And we want a window for that because we can see from the graph, it's pretty concentrated in here. And as I say that, I'm pointing to the graph because you can't actually see what I'm saying in here. So let's adjust the window 0 to, oh, maybe 10 if we like. And we did have negative, so I think negative 10, but it didn't go that high. Let's try going to 3. It gives us a little better idea of the graph. Yesterday we looked at it, so what did we say? That was 0 to 10 by 1s, and negative 10 to 3 by 1s. The asymptote line is the line x equals 0, right? Because we couldn't put in a value of 0 for x. When we went to look in the table, and we saw that x, you put in x, you get error, right? So x can't be 0. But the curve comes down along that line pretty close, right? So that's what we're looking at. Our domain then is a set of all x such that x is greater than 0. Okay, not greater than or equal to, right? Strictly greater than. And the range is y belongs to the real, since it drops down, forever, all the negatives, and then it's on a slight angle here, so it will cover all the positives, right? It will angle up. Right, okay, any questions on logs or the log graph? We're going to get into this a lot more, right? So this is just sort of an intro, and when we hit it for real, then I can say, okay, remember the log graph, and right? And we'll just go back over it, right? The different characteristics. Just FYI, the logarithmic graph is the inverse of the exponential graph, right? Just like square and square root are inverse. If you square something, square rooting is the inverse. It's undoing it. Exponential and log are inverse functions. All right, functions and function notation. So remember, a function is a relation where for every x value, there's only one y value. So what I like to do is just go through and circle the letters of the things, of the graphs here that are functions, okay, that are functions. And don't circle it if it is not a function, right? So if you can find an x value and you go in the graph and you say, hey, there's two different y values here, there's one up here and one down there, then that's not a function. So you don't want to circle that one. You just want to circle the ones that are functions. There's more than 2 and less than 6. Wow. Yeah, it helps a little. There's at least 2. Or more than 2, that means there's at least 3. Okay, is A function?
Yes.
Yes. Is B a function?
Yes. No.
Yes. C. Yeah. Okay. D. E. F.
Yes.
Yes. So F has an asymptote, and that asymptote happens to be the line x equals 2. But there is no value of x, right? You can't say when x is 2 because there's no value for that with that. It's a little hard to see, but you just have to get used to the idea of this is what an asymptote looks like, right? The curve is going to approach that line, but it never actually touches it or crosses it. Okay, so we have 1, 2, 3, 4 functions. Okay, number 5. The graph of y equals f of x is shown. So when we talk about functions, we can describe it a number of different ways, right? We could do it as an equation. F of x equals x squared minus 3x plus 2. That's what's done down here. Or here's the graph of y equals f of x. And really, that's the 6 things above those are f of x. Well, not d and e because they're not functions, right? So they can't be an f of x. State the domain and the range. So what's the domain? Which we know is x's, right? So it's a set of all x. Right. What's what's the low end? How low can you go, x-wise? Negative 5. And how high?
6.
Positive 6. So that's how we say it, right? The set of all x such that x is between negative 5 and positive 6. Or the way it's written, negative 5 is less than or equal to x, which is less than or equal to 6. Okay? Between negative 5 and 6. And how about the range? So let's write domain. Range is y's. What are the y's? Word to the y's. Y's words. Low y. Negative 2. High y. Positive 3. So negative 2 less than or equal to y less than or equal to 3. Okay? So when you're reading that, you just think to yourself, y is between negative 2 and positive 3. Right? The more formal reading is that negative 2 is less than or equal to y, which itself is less than or equal to 3. Okay? Or just saying y is between negative 2 and positive 3. Okay, in function notation, this f of negative 2 is just a shorthand way of saying, what is the y value when x is negative 2? So let me ask you, what's the y value when x is negative 2? Okay, so how do you do that? Look on the graph, right? That's the only place you have to look. There isn't a formula where we can't substitute in. We say, oh, well, let's put negative 2 into something. No, all we can do is say, all right, on the graph, when x is negative 2, y is 2. What's f at 0? That could be read f at 0 or f of 0. Or it could be read the value of y when x is 0 is negative 2. Okay. F at 4, positive 3, right? Okay. Again, if you have, if you're not sure of something, then please ask. It'll be recorded for posterity. F at negative 4, negative 1, right? So what we're doing, this is on the calculator. If we had entered a function in, this is like going second calc value, putting in the x value, and having it calculate the y value. But in this case, we're looking for the y value. Right? When it's negative 4, we get negative 1. F at negative 6.
Negative 3.
Sure?
No, not at all.
Not at all. Good.
There's nothing there.
There's nothing there.
It's an error.
Well,
Can't you extrapolate?
we'll say does not exist. It's not there, right? Because the domain goes as low as negative 5, right? This function says, as long as the x is between negative 5 and 6, we're good, right? We're defined. Negative 6 is outside of that, not defined. Okay, so this was saying if x equals what's y, this says, right, wherever you see f of x, you can always replace it with a y. So this says if y is 3, what's x? Yeah, x is 4, right? So you go along this line, because this is the line y equals 3. And we get x equals 4. Now there might be more than one answer for some of these. So if f of x equals 0, then what's x? Negative 3. Any others? Negative 1 point, what do you call it? 5? I don't think it is, but it's close enough. And 2 and 3 point, what do you want to call it? 3.4? Nah, it's more than a quarter. And
6.
You're making enough room for that one third column.
yeah, no, not much room there. Good thing I'm doing this now because we messed up. Okay, if f of x equals negative 2, or if y is negative 2, then x is negative 5. What else?
0.
0. What else? 3. If f of x equals 4, if y is 4, then x is? Yeah, which we will now abbreviate as DNE. Deny. Not quite, so that'd be DNI. Deny. Okay, moving along. Okay, so number 6, we're now given the definition of a function as a formula, right? If f of x is x squared minus 3x plus 2, okay? And a lot of times we'll see that's what we could graph this if we wanted to, right? You can go y1 equals. So another way of looking at this is saying y equals x squared minus 3x plus 2. When we say f at 0, what are we really saying?
X is 0.
The value of y when x is 0 is, okay? So what do we write for f of 0? F of 0 equals what? 0 squared minus 3 times 0 plus 2. So a function definition, it's a rule, right? This function says take your x value and do what? You square it, multiply it by 3 and subtract that from what you just got, and then add 2. Okay? So what it basically says, you see here I've got x's, and here, everywhere that you see an x in the original, you now see a 0. And what that's saying is replace the x's here with whatever's in here. Okay? And what's that equal to? 2. F at 4, what do we write? F at 4 equals, what do we write?
4 squared.
4 squared.
Minus 3 plus 2.
So 4 squared in 20 years ago? Oh, that's 4 score. What's a score?
6.
No, it's 20 years. Oh, I mean, what's the answer here? What's the answer here? I'm thinking. You know, we can fill this in if we don't have to write these, right? If you've written this here, then everything from that point on implies the left side is always f at 4, right? But it's nice to see. F at 4 is equal to 6. Okay. So if we'd gone into our calculators, plugged this into y1, graphed it, and then went to, second calc, number 1 value, and gave it the x value of 4, we would come out with the y value of 6. Questions? Concerns? Comments? How's the weather? Okay, f at negative 2. What do we do? All right, I forget what the definition was. Is it plus or minus? And we're going to get through this. So, minus 3 times negative 2 plus 2. Okay, so what do I write now? What do I write right now? What's negative 2 quantity squared? Positive 4. 4. Okay, 4. Then what?
6.
Plus, minus, times, divide. Plus.
6.
Right? Because you're going minus negative 6, which is plus 6, right? Plus 6,
Plus 2.
which is 12, right? So f of negative 2 is 12. Right, so we've looked at a function definition as, hey, here's a graph, and you can read values, right? You can't calculate anything, but you can read values off the graph. And now we have, here's a function definition as a rule as to what to do with something, right? A formula, and you can calculate. Okay, 3f of 5 is 3. Okay, what's f of 5? Well, 5 squared. So what's in this set of brackets here is f at 5, right? and then the 3 is in front, saying we're going to multiply. Now, order of operations in this case says you got to evaluate the function, right? So work out the function, work out f of 5 first, then multiply that result by 3. Okay? In a sense, you don't really have to, because you could work these out individually and go 3 times this and 3, but that would be silly, right? Let's just, you might as well just work that out and then multiply the result by 3. Occasionally I'll make mistakes. Occasionally they'll even be on purpose, and I would like you to catch them when I do, right? So if you're looking at that and going, fine, that's not right, then by all means call me on it. Okay? It could have been a mistake that I made on purpose. Probably not, because I try not to. But so it's likely just a mistake I made. Right? But you might as well call it out, right? So you sure? Is that, isn't that a 3? And then I'll look at you and say, no, it isn't. And you'll feel bad and figure you did something wrong when you were actually right. So I might push you on it a little bit too. So stand up for, if you're pretty sure that something is.
Stand up for myself.
Yeah, you all push a lot.
I'm trying, yeah.
Yeah. As I get to know you, I'll push you. I don't want to destroy you now, But if I know you, then I might push. I might push a little, right? Just say, hey, are you sure? Are you really sure? Yeah, you say, yeah, I am. Good, because you're right. Yeah, that is. All right, G at 0. What do we do? What do we write? So you're always going to write don't shortcut this, right? Don't go negative. Don't do it in your head, right? Oh, negative 2 squared plus, Don't do that. Write it down. Show the work, okay? Because it says evaluate. And evaluate sort of implies you should show something while you're, show the evaluation. Also, when you're writing that diploma, do all your work in the booklet. Right? Mark all your answers in the booklet. I always say that just in case they lose your sheet, right? Because your diploma comes down to one sheet with a sticker on it, and your answers bubbled in. And if that goes missing, then what? Right? If they have the booklet and it's marked, right? You put everything, then they can mark the booklet. If they have the booklet and it's blank, then it's like, okay, we'll give you a freebie. You can write it in August for free, right? I mean, just what you wanted to do. So mark, write everything in the book, show all your answers. Matter of fact, what I would do is I wouldn't mark any of your answers. If it were me, I wouldn't mark any answers until the end. Like I would go through the book, I would do everything in the book and not touch the answer sheet. And when I'm done, then I would sit down and fill in the answer sheet, right? Because you can bubble in then nice and dark. You won't have to worry about erasing. Just be very careful you're putting stuff in the right place, right? Like every once in a while, just check. Number 10, yes, number 10. Okay, no blanks there, right? And check your rounding. It also gives you a chance at the end when you're done, right? You're going to have time when you're done. It's like 3 hours. Trust me, you're not going to be there 3 hours. So when you're done, then you go back and check the rounding. Look at the numeric response. The rounding to the nearest hundredth. Okay, did I do that? Let me set my calculator to round to 2 and redo the calculation. Yeah, right. Okay. Right, check it out. Okay, what are you writing? G at 0. 0 plus 3 over 3 times 0 minus 5, right? It's just a substitution. Everywhere you see x, you write 0. And what do you get? Yeah, so 3 over negative 5, and then let's write that as negative 3/5. G at 4. What do we do? 4 plus 3. Over 1. Okay, G at 5/3. This is not going to be fun, but it's not. I mean, these were pretty easy. This is a little tougher. Okay, we got fractions here now. It's going to be a bit of a pain, but. Okay, so it's 5/3 plus 3 over 3 times 5/3 minus 5. It's true. That is true. It is undefined. You tell me why it's undefined.
Okay. What's up with 0, isn't it?
Yeah.
Oh, yeah.
What's 3 times 5 thirds?
3 times 5 thirds.
Yeah.
5.
3 times 5 thirds is
5.
5. Minus 5 is?
0.
Does it matter what's up top?
No.
Because you can't do what?
Can't divide by 0.
Right.
Smart.
All right. Now, let's show some work, okay, so that, you know, I actually can do fractions. So this is 5 thirds plus 9 thirds, right? So you're going to convert the 3 into thirds, right? You got to put it over a denominator of 3, so it becomes 9 over 3. What's 9 divided by 3?
3.
3, okay? So they're the same, right? Over, now we got 5 minus 5, which is 14 thirds over 0, which is undefined. Okay, I just recognized pretty quick that, hey, that's going to be 5 minus 5 is 0, so the whole thing is undefined, right? So when you get that whole big expression raised to the exponent of 0, what's that equal to? Anything to the power of 0 is?
0.
1.
1.
Right. So sometimes you got this big expression, right? And you think, oh, and then work it all down. Crap, right? It's just 1. Because whatever was in the, it doesn't matter what was in the brackets, it was raised to the power of 0, it's just 1. So sometimes you want to look ahead a little bit or just sort of, you know. But by the way, you could do this on your calculator, right? You can go 5 divided by 3 plus 3 and change it to a fraction.
1.666.
No, change it to a fraction. Just go math, enter. And it'll change to a fraction, which is 14 over 3. Because if this did evaluate, we really do want it as done, right? Oh, wow. Quadratics and radicals. We're like way ahead of the morning class because I couldn't get the smartboard to work this morning. So. That's good. So with them, I left a page undone, and with you, we'll finish the page and sit
And we'll
here
have them
and
work.
stare at each other. What makes a quadratic function? What makes a function a quadratic function? A squared. So you've got to see a squared, or if you simplify it or whatever, you're going to end up with a squared. What if you get a cubed? Is that still quadratic? Because it's got a cubed and a squared. No. What if the squared is on the bottom? No. That's too radical. That's a radical function, right? If the variable is in the denominator, it's a radical function. That's not quadratic. Okay, circle the equations that represent quadratic functions. So they have a squared, they don't have a cubed, they don't have a denominator, they don't have a variable underneath a radical sign. That would be a radical equation. They don't have a variable denominator. That would be a rational equation. So how many are, when you do it, then let me know how many there are. I'm thinking 5, but
I have 5.
yeah. Okay, how many got 5? How many got fewer than 5? How many got more than 5?
Well, I did.
Okay, this one isn't.
Because it's underneath.
Okay, because it's underneath.
I know, I did it later.
So knowing that, how many still got more than 5? Okay, so what are they?
I know,
Yep.
should've thought that.
That one? Yep. Oh, one below it.
Uh-huh.
And then
There's
the
the
bottom
two
two.
middle ones.
Yep.
But not the top middle one.
Okay, there we go. All right. It's okay to make mistakes. I mean, not on June 25th. It's still okay, but it's not a good idea. But you know, now is the time to make the mistakes, right? Now's the time to learn, and you know, we'll do stuff when you come in when we start doing the for real stuff. I'll ask you some questions out of the homework and get you to do them, but I'm not going to mark it, right? I'm just gonna, you know, I want you to be able to ask questions about it and to see how you do on it, just so you have an idea. Okay, yeah, I really understood the homework last night. I got, or I didn't have time to do the homework last night. That's why couldn't do this or whatever, right? So that's just for you. It's between you and me and whoever, but nobody else will, there's no mark associated with it, right? They're going to say, huh, you know. But there will be quizzes, those will be marked. There will be tests, those will be marked. All right, quadratic functions. When we talk quadratic functions, we're really talking this graph, right? And so we have various characteristics to this graph. So I would like you to fill in as many of them as you can. So think back, way back. All right, nobody's marking down now. I'm not looking at the stuff, you're right. Okay, so what are the x-intercepts here?
0 and 4.
0 and 4.
Oh, you already have that. I did.
Okay, is that how I write it? Do I put parentheses around them or brackets or anything? No, just that, right? X-intercepts are just numbers. If I were to throw a set of brackets or parentheses around that, it would become a point. Yeah, it would become a coordinate. It would be the point, or it would actually be this point up here, and we don't want that, right? The x-intercepts are two numbers, each number being the x value of where it's intercepting. What's the y-intercept?
0.
0. Okay, so intercepts are just numbers, right? And we've been hammering that at you for like 3 years now. So, what are the coordinates of the vertex? 2, -4. So I do anything special with 2, -4? Is that good the way I wrote it?
No, yes.
Really? You don't like those half marks? Okay, that one has to be in brackets. It's a point, right? And a point on the coordinate plane is expressed with, those are actually parentheses, right? Brackets are really the square things, but we'll call them brackets because it's got to be enclosed in parentheses, right? To say this is a point. It is the point 2, 4. Whereas these x-intercepts, there are 2 of them. They're just separated by a comma to say, hey, this is a list of the x-intercepts. What's the equation of the axis of symmetry? X equals 2. So axis of symmetry, vertical line, goes through the vertex. Okay. Since it's a line, it has an equation. So we don't just write 2, right? We say x equals 2, right, which is a vertical line. Does it have a minimum or maximum value? Has a minimum value, right? So we can circle that or cross that out or circle that and cross that out. And what is the minimum or maximum value? -4. The equation of the axis of symmetry and the min or max value are related to the vertex, right? The axis of symmetry goes through the x coordinate of the vertex. And the min or max value is the y coordinate of the vertex. What's the domain? All real numbers. What's the range?
Can you put one more?
Okay.
I just took it off.
Since it opens up, it has a minimum value, which means all of the y values are, -4, right? All of the y values are, that's a -4. It's not just sort of an extended line on the, it doesn't look at it right. Clean that up a bit. Okay, go away, come back.
It's
It's being recorded, it should look somewhat decent. What are the x-intercepts for this? 2 and 4. Y-intercept. Coordinates of the vertex. Equation of the axis of symmetry. Min or max, which one? Of? Domain. Range.
Why do you have to put that bracket around it?
It's a set. And we got a whole unit on sets.
Why does x equal 3?
Why does x equal 3? It's the equation, so the axis of symmetry passes through the vertex, the vertical line.
And x is
That's the point 3, 1. So this line has an equation which is x equals 3, right? All x values are 3.
Right, so when you figure it out, don't you add or subtract like the x-intercepts and then divide them by 2?
Okay? No, you add them. What's 4 plus 2 divided by 2?
Okay, yeah.
We're going to get there, like in no time. Right? That's actually the next thing. So this was, here's a graph, right? So on a graph door, we just read them, right? It's like, hey, it's a freebie, right? There it is. Next one, we're going to say, okay, here's some information, now calculate. So we're going to have to work for it. This, we don't have to work for anything here, really, right? It's all there. Okay, now we got to work for it. Determine the equation of the axis of symmetry for the quadratic function that has x-intercepts of 4 and 10. So what might we want to do? Draw it out, right? What does this thing look like? So does it open up or down? We don't know. Okay, do you want it to open up or open down? It doesn't matter. Let's open it up. Okay. Here's the vertex. There's the axis of symmetry, which goes through the vertex. Where is it?
7.
How do you get 7? Right, so it's halfway in between 4 and 10, right? So it's the average of 4 and 10. So we're going to go 4 plus 10. So that's 7 comma something. And it also could have opened down, right? That's why we don't know that y value. It could open up, it could open down. But we do know that that x value must be 7. So the equation of the axis of symmetry, x equals 7. Okay? So in this case, we're actually adding them because we're averaging them, right? We're trying to find the middle of them. X-intercepts of -3 and 4. Might as well open this one down just for equality's sake. Why? It's magic. Oh, look, you can almost see the top there. Okay, so how do we get the axis of symmetry? -3 plus 4. Ooh, dead zone up there for some reason. So x is a half or 0.5, right? Either one will do. Passes through the points -2, 5, and 6, 5. See my dead zone. No dead zone there. -2. That's not a good. Which way does it open? No, right? Either. There's no information given. All we know is that it does this, it passes. So let's open it up. So this time we don't have the intercept. So how are we going to figure out where the axis of symmetry is?
Just take x.
Just what?
Can you use the x values?
Yeah, just average the x values, right? As long as we have 2 x values on a horizontal line, then they must be the same distance from the axis of symmetry. That's because they call it symmetry, right? So however far it is this way, it has to be that way, as long as they're both 5 units up, right? If I have 6, 5 and -2, 3, okay, you can't work with that, right? You'd need some other way to do this. But if they're on the same horizontal line, the axis of symmetry will be right in between. So x is equal to negative 2 plus 6 over 2, which is 2.
Would we ever get any questions where they would be on the same horizontal line?
Or wouldn't?
Yeah.
Yeah, you did last year.
Then we just use your calculator.
Well, then you need some other information besides that, right?
Yeah.
But, so it's kind of like, you know, how much information do I need to solve or to get the equation of a quadratic function or to find stuff out about it, right? So, you know, give me another point so that I can work out an a value or, and you know, in 20-1, those of you who did 20-1, you would do a system of equations, right? You wouldn't know a and q, but you could do a system and calculate it. Yeah, in 20-2, we didn't do that, right? We had other ways. So if you're coming from 20-1, there's certain things that we have done in 20-2 that you haven't, okay? But you'll see them and they'll hopefully make some sense. And you're free to use methods that you used in 20-1 to do stuff if need be, okay? So, you know, if you want to do something that way. So as long as what you're showing is mathematical, makes sense, follows, then I don't care, right? When I ask you to show your work, if I could see the work and I say, okay, yeah, you did it that way, that's fine, right? If it's garbage, not so fine, right? I mean, it's like, yeah, you got the right answer, but, you know, and if I give you 0 on something, you say, but I had the right answer, and I say, okay, but what in the work tells me that you got the right answer, right? So I need to see something sometimes. All right, x-intercepts, what are they? Close. -4 and +2. How do we get the? How do you get x-intercepts? What do you do to get the x-intercepts?
Just say that one, that one.
It's a 0.
Okay, what 0? When you want to find the x-intercepts, what 0?
This guy. No, y is 0.
Yeah, you set y equal to 0. So in this case, you get 0 is equal to 3 times x plus 4 times x minus 2. So if x is -4, that whole expression is going to become 0. Right? You get 3 times 0 times whatever. Who cares? Doesn't matter, right? Because it'll be 0. If x is 2, you get 3 times 6 times 0, which is 0. So that's what we want. So from factored form, x-intercepts are easy to find, right? You just set x plus 4 equal to 0 and solve for x. Say, what value of x makes this 0? -4. How about this? +2. What's the y-intercept? That's actually going to require work. So to get the y-intercept, what do you have to do? You set what? Set x equal to 0, right? So y-intercept, you set x to 0. X-intercept, you set y to 0. If I set x to 0, that'll give me 3 times 0 plus 4 times 0 minus 2, which works out to 3 times 4 times -2, or -24. Is that me?
Yep.
Did you get the water?
Did you get the one?
Yeah, I did.
What's water?
Yes.
What's water?
Agua. Oh. Can't remember in German what water is. Let's give it to you.
In the world.
H2O, dihydrogen monoxide. I don't know.
You can use it.
It's wet. What's the equation of the axis of symmetry?
Use it to play with.
Sorry? X equals really? Yeah, it is. Huh. How'd you get that?
Get 0.
That's good.
-4 plus 2.
Yeah, if you have the x-intercepts, right, those are 2 points on a horizontal line, in this case the x-axis. So it's halfway between them. Okay, so x is equal to -4 plus 2 over 2. All right, so how do I find where the vertex is?
You take the first point from your axis of symmetry, which is -1, and then you take.
So we're going to work out y when x is -1, which is what f of -1 says, right? only without using a whole bunch of words. F of negative 1 says, well, what's the value of y when x is negative 1? Why do you want to know that? Because negative 1 is the x coordinate of the vertex. And if I stick that in, then I'll get the y coordinate of the vertex. So that's 3. Which is so it's negative 1, negative 27. Let's say this was on a test. What does state mean? What do you have to do? This is on a test and it says state. What do I need to see?
The number.
Just the answers. Okay? You don't need to show any work. All right? So if all you did is write negative 4, comma 2, negative 24, x equals negative 1, negative 1, negative 27, full marks, right? So you don't have to show work. Y-intercept of this. This one's easy.
14.
Yeah. You set x to 0, right? That takes out the x's. So this is factored form, right? Factored form.
Can I go to the washroom?
I don't know. Did you drink a lot of water?
Yep.
Then you could. This is standard form. I remind myself sometimes this is all recordings. To find the y-intercept in factored form requires work, right? Because you got to put in a 0 for x and you got to do some work. To find the y-intercept in standard form is no work. You just got to just say, okay, ignore the terms with x's in them, right? Because they'll be 0 and it's just 14. The equation of the axis of symmetry. This is work. So how do we do this? Yeah, sort of, but no. Well, it won't factor. There aren't two numbers that multiply to 14 and add up to 8, right? There's 1 and 14, 2 and 7. But what we could do is something that you might remember we did last year. It's called partial factoring. Okay? So if you did 20-1, you've never seen this before. But it's kind of cool. So what we're going to do is this. Just say y equals x bracket x minus 8 plus 14. So partial factoring says, let's just factor the first two terms, right? The x squared and the x term. And that's what we get. And then we say, you know, if x is 0, then y is going to be 14. Because if x is 0, these guys are gone. Okay? So if x equals 0, y equals 14. And then you say, if x equals 8, then what's y equal to? And why did I choose 8? I mean, it wasn't random. Yeah, 8 is the value that's going to make the second factor here 0, right? So if x is 8, 8 minus 8 is 0, times 8 is 0, I'm going to get 14. I now have 2 points, 0, 14, and 8, 14. Those 2 points are on a horizontal line, right, because they have the same y value. So what's the axis of symmetry without doing too much calculation? 4. Right? So what we have found, I'll just kind of graph it, right? 0. We get these 2 points, right? 0, 14, and 8, 14. And so we know the axis of symmetry is halfway in between. Method that we use is called partial factoring, right? It says just factor these first two, the ones that have the x's in them, and then set them so they'll be 0. Okay, make that 0. It's like doing this, only that's fully factored, right? So what value of x makes that 0, right? Negative 4. So that actually is an intercept. But let's make this 0 because we're going to get 2 points on a horizontal line, then we can figure out the axis of symmetry. Okay, what do I do to get the vertex? Well, we know the x coordinate of the vertex, right? It's on the axis of symmetry. So we know x is 4, we have to figure out what y is. Okay, how do we do that? We work out f of 4. All right, which is what? 16 minus 32 plus 14, which I think is negative 2. So 4, negative 2. Yes. I won't say that's right. I'll say it agrees with the key that I had, but I already found a mistake on the key earlier today, so it means nothing. Wow, keys are more often right than wrong. It's like your book, right? There could be mistakes in the back of the book as far as answers go, so, you know, don't get too upset if you can't find the answer. Just, you know, flag it and then come ask about that question. I don't know, I'm not getting the answer they haven't found. I wouldn't spend like 3 hours working on it or anything. You try it, you look at the answer, that's wrong. Try and get their answer. But, you know, don't spend an hour doing it, right? Because maybe they're just wrong. This one is in, all right, what do we call that form? Vertex form. This is in vertex form. So 3 forms of quadratic equations, right? Standard form, ax squared plus bx plus c, factored form, and vertex form. So if it's vertex form, what's the vertex? Negative 3, 4. Okay. So vertex form, we can read the vertex. Those of you who did 20-1 know how to convert from standard form to vertex form. Right? Or you may know how to convert. Standard form. You were shown a way to convert from standard form to vertex form. Right. We never did that in 20-2. We don't have to know that, right? We can figure out where the vertex is, like we did in the middle one. So if I want vertex form for the middle one, it's okay. I've got it, right? It's x minus 4 quantity squared, and right, minus 2. Because you've got the vertex, and that's vertex form. I know it opens up, and I know that a is 1. So it's just y equals x minus 4 squared minus 2. So we can get vertex form if we need it. There's many ways to do that, right? And having said that, if you know how to complete the square and you got to get into vertex form, by all means go ahead, do that. Which way does this open? Down. How do we know?
It's a negative.
Right, negative in front, right? That tells you that it's reflected in the x-axis, it opens down. Equation of the axis of symmetry. Yeah. Okay, I mean that's easy, right? Because we've got the axis, we've got the vertex, so we know that. X-intercepts. That's not easy. X-intercepts, what do we have to do? We got to set y to 0, right? So we're going to go 0 is equal to, actually we're going to, hey, give me an eraser. Hang on, I'm going to save this. Save. Before we use it. What, you got 4 other kids to send? No? 72. I didn't look at names. But I'm just worried about how I word.
You're going to put it on Weebly so that you could, whenever you don't understand something, you could watch the class lecture again.
You don't know the word, you don't know all the words.
Okay. Who did I send you this morning? I don't know. I didn't ask for names. So let's do this. Negative. Okay, so to find the x-intercepts, you set y equal to 0, right? So that's what I'm doing. I'm writing it on the right because I like it better there. And then what we're going to do is we're going to move the 4 over. And then what we're going to do is we're going to divide both sides by -1, or multiply both sides by -1, because we want to get rid of that negative. So it becomes x plus 3 quantity squared is equal to positive 4. Okay? And then we're going to square root both sides. And this becomes x plus 3 is equal to plus or minus 2. Because the square root of 4 is positive 2, but also negative 2, right? Because there has to be 2 answers. I mean, if you graph this thing, you'll see there are 2 x-intercepts. We have to be able to find them both. So, that means that x is equal to -3 plus or minus 2. So we get -3 plus 2 which is -1, and we get -3 minus 2, which is -5. And so the x-intercepts are -5 and -1. You did this last year, honest. Okay, you were taught this last year, honest. I don't know if you did it or not. You don't remember this, right? You're looking at it, okay, but it'll come back to you, trust me. Yeah. Y-intercept, how do we get the y-intercept? How? Not what?
You just expanded the
What do we set to what?
x to 0.
Yeah. So, -5. Got the negative. The negative is outside the squared. It's the negative of 3 squared. So it's -9 plus 4. Okay? You can always go back and review this, right? I mean, we're 51 minutes in. They won't all go like this, right? In 30-1, yeah, every class is pretty much blah, blah, blah for 80 minutes, and then, okay, go home and do a couple hours of homework. I'm going to hopefully not have that here. I'm hoping class will, a half hour of discussion, whatever, and then, okay, now do some work. Solve 2x squared plus 12x plus 13 equals 0 by graphing on your graphing calculator, round to the nearest hundredth. Okay, so I'm going to pull in the graphing calculator. Let's turn it on. Let's go to y equals. I'm going to clear that. See, it works now, right? And we're going to enter 2x squared plus 12x plus 13. And we're going to hit graph, and we're going to go, whoa, who set that? And so I'm going to go zoom 6. Go to a standard window and say, good enough, right? I mean, for what we want to do, this window is good enough. If I wanted to display this nicely, I'd kind of adjust the window to shift over a bit. I want to find the zeros, but I don't like finding the zeros, so I like setting y2 to 0 and finding the intercepts, right? So you have 2 ways to do this. You go second calc. You can find the zeros, which means you do a left bound, a right bound, and a guess. That's too much work. So I do intercepts. And so all I can do is trace along until I find... Put that up. Trace along until I get to there. Okay, pretty close to the intercept. Hit enter 3 times, right? First curve, second curve, and guess. And guess. So, negative 4.58. Comma. And I want the second one. So, second calc, intersect. I'm going to move along the straight line because it's faster. And hit enter 1, 2, 3. And negative 1.42. Okay, any questions? Besides, you went way too fast. I know. Okay, I'll do the next one slow.
Is that all you have to get?
That's it.
And it says solve.
Okay, let's go. I'll go back through. So I'll show you what I entered, right? And you can always just remember this. It's at like 54 minutes in, right? So you can just sort of scrub ahead to like 50 minutes and then watch, and you can stop, pause it, and then, because I'm typing stuff in. And if you're watching this, on YouTube, you can obviously, hit pause and then type in the stuff yourself, right? But here's what I did. So I put in y1 was the function, and I put in y2 as 0. And the reason I do that is, the other way to do this, I'll show you, you hit graph, is you go second calc, number 2 for zeros. I want to find the 0. Then it asks you for a left bound, so you need to go to the left. So I'm going to hit enter. And it asks for a right bound, so you go up to the right and you hit enter. And then it asks for a guess, so you move down close to the 0 and you hit enter. And it gives you the value. Okay, so that's using zeros. The other way is, by graphing y2 equals 0, I've actually drawn a line along the axis, and then I just say, where do these two intersect? because the intersect, so I go second calc, number 5, intersect, and then all I do is move close to the 0, and I hit enter 3 times. And it moves from one curve to the other curve, and then asks for guess, but I'm already there, right? Because I'm lazy, so I just move about to the spot, and then just go, and then you get your answer. Okay, this one, so I'm just going to hit clear and clear. Solve 3x squared, so 3x squared, 3x squared, plus x plus 6, and 13x minus 2. Okay? Going to take time. Now you can enter stuff, right? I'm giving you lots of time. So we just entered y1 is this one equation, and y2 is the other equation. I'm going to hit graph. Let's see what this looks like. And I'm going to say, whoa, okay, this I need to adjust, right? Because stuff is happening up here. And so I'm interested in maybe like from, let's say, -5 to 5. And this is like 1, 2, 3, 4, it's like 5 or 6 up. So I'm going to set my window from -5 to 5 by 1s. And I'm going to set the y to go from 0 to 50, let's say, by 5s. Is that nice?
It's nice.
It's a lot nicer than the other one, right?
Yeah.
And look at that. And we can see there's 2 distinct intersections there, right? And that's what changing your window does for you. It allows you to see stuff a little more clearly. Use your table to help you do that sometimes. You can go into the table and look and say, hey, when are these y values about the same? Because that's really what we're looking for, right? Is when are the y values here about the same? So 10 and 11, that's pretty close, right? So I know that I want to be somewhere in around 1, and then 58 and 50, you know, so somewhere in around there. But it means that I need to go up as high as 50, right? And that's what I did. Okay, so second calc intersect. So move close to one of the intersections, which is right about there, and then hit enter 3 times, right? First curve, and it's on y equals 3x squared plus x plus 6. Second curve, and it moves to 13x minus 2. Guess, I'm there, so I just hit enter. And we get 0.85. And then we repeat. This time we're going up here, so second calc intersect. I can only hold down for 3 seconds before that other menu pops up. So I get really close to the intersection, hit enter, 1, 2, 3, and 3.15. Okay, so that's my 2 answers, right? 0.85 and 3.15. Solve by factoring, your favorite thing, right? Everybody loves to factor. Express solutions as exact values.
Since everyone loves to factor, there are going to be so many factor opportunities.
Oh, wow, okay. Let me tell you, when I wrote the diploma, there's some factoring. It comes in rational expressions. So one of the units that we look through is rational expressions. And when we get to it, it involves factoring. It's not real difficult factoring. And the most important thing when you factor is check that you factored properly, right? Because usually what people do is they've got the numbers right, but they get the signs wrong. So you end up with, if you expand it back out, you know, oh wait, I got a -5 in the middle when I should have had a +5. And if you do that, and you get, it's just wrong, right? But you have the right numbers, you've got the right procedure, you know what you're doing, and on a diploma exam, you're losing 1.25% of your final mark in the course, right? Because there's no recourse. It's not like, here I can look at it and go, okay, half mark off, you got your signs flipped, right? You get 1.5 out of 2. On the diploma, you get 0 out of 1.
You're so mean.
It's not mean, there's realistic. Right or it's wrong. It's very binary. So check it over. You've got lots of time. They're giving you 3 hours and 5 if you get extra time. So you've got lots of time. Take your time. Seriously, on the diploma, take your time. Work through. Read the question. Read it a couple of times, right? Sometimes you're going to answer the question you think they're asking. Oh, we did a bunch of those in class. That's not actually what they're asking for, though, right? But the answer will be there to what you think the question is, right? It'll be one of the 4 answers, because they'll say, you know what, people are going to think this question is asking for this thing because they've done that a bunch. But no, we're turning the question around a little bit and asking for something different. So read it carefully, right? Take a highlighter out, highlight parts of it, right? Make sure that you understand, what do they really want me to find here? Also, one of the big things when you're doing multiple choice, ask yourself why those other answers are there, right? They're not random numbers. They didn't just pick numbers out of the air, right? They chose numbers. So you ask yourself, well, what kind of mistake would you make to get that number? Well, you do a -2 instead of a +2, right? Like it's a vertex thing in that. Oh, wait a sec. I did the -2 instead of the +2. So that might be the mistake you made, and you can catch that then, right? It's, oh, yeah. So look at those and say, why is that there? Okay, factoring. This is a difference of squares, and so this is how a difference of squares factors. Difference of squares, they're both squares. They have square roots, right? X, the square root of x squared is x. The square root of 121 is 11. X plus 11, x minus 11. FOIL it out, make sure, right? X squared minus 11x plus 11x is 0 x's minus 121. Solve. And get your 2 answers, right? -11 and +11. Right? So if you have any at any point you have any questions, ask. Right? You know, or come in tomorrow and say, hey, I went back through that and I still don't understand what you did on this one thing. I just didn't want to ask in class, which is fine, so don't ask. But you know, get it straightened out somewhere, somehow. Go into Henry's after school and say, hey, can you explain this to me? We just did this in class, I don't understand that. 5x squared minus 9x. This is a common factor. I won't erase that. All right. Okay, with 2 terms, right? 2 terms, it's either a difference of squares, in which case you're going to see a minus sign and things that have square roots, or it's common factoring. This thing has a minus sign and they have square roots. This thing, there's no square roots, so this is common factor, right? Which means that either x equals 0 or 5x minus 9 is equal to 0. So 5x is equal to 9 and x is equal to 9/5. When you're doing a numeric response question and you're getting an answer, you know that they are always what? They're always positive. So anytime you're doing a numeric response and you want to be writing a negative sign down, you can't. There's no place for it, right? So they're always positive. You get a negative answer, you messed up, right? Or they're asking you a question and they're saying, you know, when the answer is expressed in the form a root b minus c, then, you know, there will be a negative there. You're subtracting the c, but they're just asking for the value that goes in there. This is just trinomial factoring, right? Okay, so I know that I have to lead off with x's, right? It's x and x. That's how I get the x squared. I know that the last 2 numbers have to multiply to 70 and differ by 9, right? Difference between them. So 1 and 70, nope. 2 and 35, nope. 3 doesn't go in. 4 doesn't go in. 5 and 14, yes. 5 and 14 differ by 9. The larger one is negative, so let's go minus 14 plus 5. Now I factor by guess and check. I was just guessing what the numbers were. Now I'm going to check. Foil it, right? It takes, what, 30 seconds to foil if you're really taking your time. Otherwise it takes like 5, right? X squared plus 5x minus 14. Plus 5 minus 14 is minus 9. Minus 70, right? Negative times a positive. Okay, good. Factored. Answer? 14 and negative 5. Okay. 3x squared plus 11x minus 4. I know that one of the factors has to have a 3x up front, right? And the other one's an x. It's the only possible way to get 3x squared. I know that the final two numbers have to multiply to 4. It's either 1 and 4 or 2 and 2. If I put a plus 4 here, that'll give me a plus 12. And if I put a minus 1 here, that'll give me a minus 1. 3x squared plus 12x minus 1 is plus 11x minus 4. Okay, x is equal to 1/3 and negative 4. If you need to review factoring that, there's a lot of videos on YouTube. I have a bunch, and there's a bunch on YouTube. You can just sit down and you know, just watch something until you find something that makes sense to you, right? Like if factoring never made sense to you, go out there, you know, watch a bunch of videos. If it's not making sense, stop it and watch another one. Eventually you'll find one and go, hey, that makes sense, right? I could do it that way. Yeah, it's drawing boxes and stuff, but so what? I like drawing boxes, right? There's ways to that where you draw a bunch of boxes down and you put numbers in the box and stuff like that, right? And maybe that works for you. You're very visual and just, hey, if I can see boxes and that, and, you know. What works for you? I'm a diploma. Nobody cares, right? They're not going to look through and say, look at that person factored with boxes. They're not the only way they're ever going to look at what you wrote is if you appeal, right? And it could be, if you get your mark back and it's like, there's no way. I did not score 35 on the multiple choice, right? I mean, it just can't happen. Then you can appeal that. And it could just be an error in the way that your card read or something. So they'll look at that and then they can go pull your book and they'll look at the book and say, oh, you know what you did. You put the answer to 3 and 2 and then you carried on that way. So all right, we'll go back and we'll look through your book and mark that. Solve using the quadratic form, express solutions as exact values. When you see exact values, if I see a decimal, I'm just going to cross it off and say no or something. Or, you know, unless that decimal is like 1.5, right? Because that's an exact value. But when you're getting into stuff like you know, when you've got 3 plus or minus root 7 over 5, if I want exact values, then you're leaving it in that form, okay? Don't convert it to, don't go into your calculator and work it out, right? I don't want to see that. If it says rounded to the nearest 100, then I do want to see that, right? I mean, then we want that value. Okay, identify A, B, and C. Write down the formula. I always write it down even if it's in front of me. Not that I can write it right. Come on, where's my erase? Why won't you erase? Useless. Look at that. Oh, of course, now it disappears. Yeah, this is like longest video yet. Minus 4AC, that's a minus over 2A. Write it down. One of the things you're going to do when you get that diploma, and one of the things you do in class, is you're going to have a formula sheet. Use the sheet. Do not assume you know it, right? Because you don't. And you'll write it down and you'll get a sign wrong, or it'll be, you'll put a multiply and it should have been a minus or something. So have the sheet in front of you. Use it. No matter how well you think you know a formula, just take it off the sheet. Right? What's it hurt? Okay, I've got negative 5, so I'm just going to put down a 5, right? Positive 5. A, B, C. Oh, sorry. Yeah, in standard form, it's written in the form ax squared plus bx plus c.
I thought you'd know.
So, sorry. Should have mentioned that, I guess, eh? Okay, so standard form equations are of the form ax squared plus bx plus c equals 0, and that's so I get my a, b, c. This is always positive. So don't even type the negative in when you're squaring it in your calculator, right? Because I see people putting negatives. I hate that. Right? It's like negative 7 squared is negative 49. Yeah, because in your calculator you wrote negative 7 squared and hit enter and it gave you negative 49. Because you didn't go bracket negative 7 bracket squared, which would have given you positive 49. So just remember, look, that's always positive. B squared must be positive. Okay, so we get 5 plus or minus the square root of 25 minus 8 over 4. So x is 5 plus or minus root 17 over 4. That's exact. Okay? You're not going to give me a decimal equivalent. That's just a waste of time if you start punching in your calculator, right? And a waste of marks, because I'll ding you a half. If you then go and give me more than I want, and I didn't want that stuff that you give me, I'll just cross it off and say minus a half.
Really?
Really? It wants exact values. Stay exact. I don't know. Maybe not. It depends. 8x squared plus 8x minus 1. Okay, same deal. Identify A, B, and C.
I don't like this. A being negative underneath the radicals.
Because you screwed up.
No.
Underneath that one there?
No.
This one?
Yeah.
Yeah, you messed up.
A being
First of all,
negative 6.
you know, okay, I'm going to tell you why it can't possibly be negative. Here's why. B squared, that's always positive, right?
Yeah.
Okay? You're subtracting, 4 is positive, A is positive, and C is negative. So you're subtracting a negative, therefore you have to add. So it can't be negative. You have something that's already positive with the B squared, and to that, it's 64 plus. Look, minus negative 32, which is plus 32, which is 96.
Yeah, what's my bad?
I know. I'm sort of skipping a bit here, right? That's 64 minus negative 32, which is 64 plus 32, or 96. I'm saying it. You can watch this and see the little red line moving at the bottom here? Okay, there, good. It's on. It's on. So the green line, yeah, okay? Now, root 96 simplifies. It's a radical. So root 96 is equal to the root of, 96 is 16 times 6. I'm looking for a perfect square. We're going to do a page of this in a second. Okay, so which is root 16 root 6, which is 4 root 6. So this becomes x is equal to negative 8 plus or minus 4 root 6 over 16. Okay, now is there anything that goes into 8 and 4 and 16? How about 4?
4.
2 does, but so does 4, right? Okay, so it has to go into all three. So if this was negative 8 plus or minus 3 root 6 over 16, you're done. You can't just go and say, oh, but these two, no, it's got to be all three. Okay, so 4 goes into all three. We divide everything by 4. We get negative 2 plus or minus root 6 over 4. That's your answer. Simplified radical form. Okay? Now, what they'll do is this. So on a diploma, they might ask you, the solution to this can be written in the form negative a plus or minus square root b over c. And they'll ask you for the values of a, b, and c as a numeric response. So the answer would be 2, 6, 4. Right? So they'll say, you know, the answer to this, when it can be expressed, or when in simplified radical form, right? Because the answer to this is also negative 8 plus or minus root 96. They'll say the answer to this in simplified radical form can be expressed like this. Write the values of a, b, and c. Okay, so. These ones, this is your, let's pretend we're doing 30-1.
Yay.
Yeah, did I not have a negative 8? Hang on, we might have had something wrong. Oh, yeah, negative 8, negative 2. Everything is divided by positive 4. So, yeah. So that 8 up front was negative, right? Because the b was positive, so it became negative b, negative 8. Okay, sorry, I was afraid that I hadn't. you know, we're not going to get much further than the morning class did anyway. This is what 30-1 is like every day.
Nice.
Right? Right? Verify that. Is that what 30-1 was like? So you were what, there for 2 days, right? You were there for 2 days. It was like that every day. And it's, seriously, it's what it's like almost every day. It is just like 80 minutes of
Talking.
Yeah. Yeah. This is exceptional, right? I mean, just because we're actually working through a worksheet together. So, you know, by tomorrow, we'll probably have to finish some of this tomorrow, and then, you know, when we get into the lessons, I'm going to try and keep them reasonably short. I'm going to try and stay away from the textbook. Like last year, I just sort of taught out of the textbook the examples that were in there. I'm going to try and give you different examples. I like the book, and I want the book to be kind of yours, so that that's something that you can go and look at and read as an alternate explanation, right? It's something else, so that if you're not going to say, hey, let's look at the book and see what it has to say, and let's look through the examples in the book. And I'm going to try and keep away from that. You know, that might last a day or two.
Still keep
But well, keep bringing the book because you need it. No, I'm not going to do the booklets, but I'll come up and I'll just say, hey, this is the idea that we want to cover, and here's some examples of how to do that, and let's do a few, and then, okay, now, your turn. Okay? And then you can go read in the book, and there's other examples there, so you can look through and say, well, wait, you didn't do anything like this. Okay, but the book has an example of that, so you can look at it.
Okay.
All right, root 50. So you may remember radicals. You spent a unit studying them, but if you're like the 10Cs, and you did it in 10C, right, which never actually carried through to 20-1. I just taught them, and it's like, really? Come on, you did a unit on radicals. So we want to simplify radicals. So root 50, what we're looking for is, if it's a square root, we're looking for the largest perfect square that divides into 50, which is what? 25. So we're going to write root 50 as the root of 25 times 2. And then we're going to split that out. And we're going to write it as root 25 root 2. And then we're going to write that as?
2 root 5.
Yeah, no, we're not.
Oh, 5 root 2.
Yeah, yes, we are. Okay? So 5 root 2. Now, if you want to look at 50 and write 5 root 2, I'm okay with that. I don't need to see any work. You look at 72 and you say 6 root 2, good for you. You look at cube root 24 and you say 2 cube root 3, good for you. Okay? So I don't need to see work on any of this, right? But I'm going to show you the detailed work, just so that, you know, if you need to, use it, and if you don't, right? Some things you'll learn, right? Like you'll look at root 8 and you'll just know root 8 is 2 root 2. How do I know that? Because 5 questions I've done with the root 8 already. So I know it's 2 root 2. Okay, root 72. Okay, I'm going to do this not wrong, I'm going to do this long. 72 is 9 times 8, right? And 9 is a perfect square. Okay.
Yeah, it's 3.
So this is root 9 root 8, which is 3 root 8. Okay? But I'm not done, because 8 is divisible by a perfect square, which is 4. So this is 3, and the root of 4 times 2, which is 3 root 4 root 2, which is 3 times 2 root 2, which is 6 root 2. Okay? Yeah, that's the... You know, if I'd have been thinking about this a little bit harder, okay, don't write this down because you don't want to do that. Come on, give me the eraser. Okay. So, it sort of randomly. The largest perfect square that goes into 72 is 36. Okay? And so this becomes root 36 root 2, which is 6 root 2, right? All right, one more, then we're even with the other class. You can have 3 minutes, which they didn't get. This is a cube root. I need perfect cubes. What is a perfect cube that goes into 24? 8, right? Because 8 has a cube root. So this is equal to the cube root of 8 times 3. Which is cube root 8, cube root 3, which is 2, cube root 3. Don't leave off the little cubey root things, right? Don't leave off the little 3. That's called the index. Don't leave off the index. Wow, that was an exciting 7